So looking at page 6 in the Unit 3 packet, the questions are asking us to solve each system of equations graphically. A system of equations is a set of two or more equations sharing the same variables. All right. The solution, a graphical solution of a system of equations, is really just asking for the intersection. So all you'd have to do is graph our two lines. So in this case, rewrite them. They're in nice, convenient y equals mx plus b form. So it should be pretty easy to graph. We graph our two lines. I have a slope here of 4 and a y-intercept of -1. A slope here of -1/2 and a y-intercept of 8. Once we create the graphs, then we just see where they cross, and that would be our solution. All right, so with a y-intercept of 4, with a y-intercept of -1 and a slope of 4, 1, 2, 3, 4 over 1, because remember 4 is the same as saying 4 over 1. Both are positive, so up 4 to the right 1, up 4 to the right 1. But we could also look at this as being the same as saying -4 over -1. So down 4, left 1, down 4, left 1. All right, draw a nice line passing through those points. Label it. All right, and then we have our first line. Now our second line has a y-intercept of 8, so 1, 2, 3, 4, 5, 6, 7, 8. With a slope of -1/2, -1/2. So that could be -1 over 2, or we could write it as 1 over -2. If it's the first case, that would be the same as saying down 1, right 2, 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 right? If it were the case of the second one, that would be the same as saying up 1, left 2, all right? Up 1, left 2. We can do that a couple of times. Draw a nice straight line through all of these points, and take note of the intersection, which appears to be right. Yeah. All right, so the intersection is at an x value of 2 and a y value of 1, 2, 3, 4, 5, 6, 7. So intersection or solution would be 2, 7. It's an ordered pair. All right. For the second problem, it's similar. It's just you have to take an extra step to get started. We have our first equation, y equals x plus 2. Our second equation, 3x plus y equals 10. All right, I would subtract a 3x from both sides. So we would call this y equals -3x plus 10. All right, because remember that 10 is an assumed positive. All right, you could put these together any way you want. I choose to put the -3x first because we want to have it in y equals mx plus b form. So we have a slope here of 1, a y-intercept of 2. That 1 could be thought of as 1 over 1 or -1 over -1. Here I have a slope of -3, which could be thought of as -3 over 1 or 3 over -1 with a y-intercept of 10. All right, so if I plot a y-intercept of 2, so for the first equation, y-intercept of 2 with a slope of 1 over 1, I would get this line. nice straight line through those points. Give it a label. Draw the other line, so that would be a y-intercept of 10. 3, 4, 5, 6, 7, 8, 9, 10. So it's right at the top. Down 3 or right 1 seems to make the most sense. And that actually gets you to your intersection pretty quickly. Nice straight line. Although it didn't look like it was going to be that way, but it ended up being that way because of autocorrect. Okay, that's the best I can do. And so give it a label with the original equation 3x plus 10, y is equal to 10. Our solution would be where the two cross, which appears to be at 2, 4. All right, so 2, 4 would be our solution. Now, if a question doesn't ask you to show any work, you could just use Desmos. Y minus x equals 4. 2x plus 3y is equal to 27, and see where they cross. All right, so we get a solution of 3, 7. All right, but you could also, from Desmos, get some points to plot. All right, so you go along this graph, you see some nice convenient points that you can use to plot the graph. All right, so doing that is pretty good strategy here. Like, for example, the black one, I can plot -4, 0, comma, +4, 0. Comma, 0, +4. Draw a nice line through those 2 points. I want to make it look reasonably correct. If you need a few more points, grab those extra points. All right, we know that it's going to cross with the other line of 3, 7, so we make sure 3, 7 is part of the graph. Now the other line, we look at that one and we see it has an x-intercept of 13.5. Well, that's off the page. All right, so we grab another point along the way, something convenient. Looks like we got a decent y-intercept here, 0, 9. And we know it's going to go through the intersection point. So we have our graph, y minus x equals 4. 2x plus 3y is equal to 27. And without having to show too much work, we have our solution of 3, 7.